In this lecture, we are discussing about BW subject of BTech first year. In this lecture, we are mainly discussing about single phase AC circuits. So AC circuits are vastly used in industries and also for domestic purposes. AC supplies are that source which changing its direction with respect to time. The major difference between AC and DC is that DC are subtracted and added arithmetically, whereas AC are subtracted and added vectorically. We can understand this by an example that in this circuit the direction of current is this, and after some time the direction changes to this. So if we plot a sinusoidal waveform, what are waveform? Waveform, the manner in which voltage or current changes with respect to time. So in this direction the current reaches to its maximum value, which is this value, and after reaching to a saturation point and a maximum value, the direction of current become reversed and it going to opposite direction, that means that direction, and after reaching to its saturation point it again changes its direction. So why? Universally only sinusoidal waveforms are taken for the for AC purposes. So there are three reasons the sinusoidal are used. First, you can see this. First, less iron and copper loss, which means flux. Second, less disturbance to circuits. And third, less disturbance to telecom, means communication. These are the three reasons that sinusoidal are used. After that, we know that electricity and magnetism are related to each other, and this relation is given by Michael Faraday. So, we know that AC can be generated by AC generators, both EMF and current generated by an AC generator. So, let's take a rough example. Here are poles and this is a coil and these are rings. So, when suppose the direction of the coil is this, and when its direction is perpendicular to the flux passing through it, then the current reaches to its maximum value, and after that when its direction becomes changed, then the end become oppositely polarized, and then the direction of current become changed. So this is the working of AC generators. So AC generators are basically depends on three factors. First, speed, means the speed of the coil. Second, strength, means the strength of magnetic field. And third, length. Length means the length of the coil. So the speed is depend on the frequency of the coil, because frequency is defined as the number of turns in a unit time. So there are more number of turns, means more frequency. So frequency is directly proportional to N, means rotation per minute. And also F is directly proportional to P, where P are number of poles. If there are more number of poles, then more number of cycles are generated. With these two, F is directly proportional to Np. F is equal to Np by 60, where this 60 is for second, means here RPM, rotation per minute, and here rotation per second. So we divide with 60. The unit of frequency is Hertz. Secondly, the formation of this sinusoidal can be understood with the help of phasors. So let's take an example. We will discuss it into detail, but here is only an example. This is a phasor and OA is showing the max magnitude. So When this move in counterclockwise direction, CCW, counterclockwise direction, then the projection of OA on baseline shows the magnitude. So when with the help of triangle OAB, sin theta is equal to E by E max, because OA is max. When OA reaches to this point, then this point is corresponding to the peak value. So this OA is the E max or I max. This OA is E max or I max. So sin theta is equal to E by E max. We shift E is equal to E max sin theta. Where E is voltage, V is equal to Vm sin theta. After that, we more precisely divide this phasor. We more precisely find the waveform. I hope you understand. So, according to Faraday's law of electromagnetic induction, E is equal to minus n d phi by dt, where this negative sign shows the opposite direction of EMF which is induced by the source. We know that at any instant of time, the flux passing through this coil is phi is equal to phi m cos omega t. Putting value E is equal to minus n d phi by dt. Putting the value of phi, differentiating with respect to time, we obtain E is equal to E max sin omega t, where the value of E max is n phi m omega, where phi m is the maximum flux, or we can say that peak flux which is passing through the coil. Let R is the resistance, then with the help of previous equation, IR is equal to IMR sin omega t, and R cancelled, I is equal to Im sin omega t. This is the equation for alternating current, AC current. After that, important term, alternation. What is alternation? 1/2 cycle or 180 degree electrical degrees, which means if if this phasor complete is 180 degree from 0 to pi, which means this. So it is considered as an alternation. What are phasor diagram or sinusoidal waveform? So this can be understood by an example. Let's suppose I is lagging behind V by phase difference phi. This all things we are studied in our previous classes, and here is the detail of all these things, where this line is the reference line also for this waveform, or we can say that here it is a horizontal and this is vertical. So this reference axis is the horizontal for this waveform. So we can say observe that V is equal to Vm sin omega t. It start from the reference line, therefore it start from this point, and I is equal to Im sin omega t minus phi, which is behind or lags by the phase difference phi, is start from this point corresponding to this, and they plot and they make a waveform in their individual manner. So we can say that current is lagging by phi phase difference. So we are familiar with the phasor addition, phasor subtraction, है ना, with the triangle law, है ना. Suppose there are two phasor V1 and V2, है ना, then the resultant is this, Vt is this. Phasor subtraction, we are familiar with the phasor subtraction. If one phasor is this and another phasor is this, then V total is equal to V1 minus V2, because this is in negative direction. And the new thing is, the new inverse syllabus is rectangular form, in which phasor is divided into real and imaginary parts. Let's suppose z is equal to x plus iy. Phasor addition using rectangular form. Suppose V2 is a phasor, and V2 is a phasor of 30 volt. We can assume the theta is 0 degree, which means it is along the axis, along the axis. So theta is equal to 0 degree. If we split V2 into two rectangular components, horizontal component we know that 30 cos theta, and vertical component we know that 30 sin theta, where theta is 0, cos 0 is 1, so 30, and sin theta is, sin 0 is 0. So we obtain V2 is equal to 30 volt, which means this is sum of V horizontal plus V vertical. Secondly, we take another phasor. V1 is equal to 20 volt, theta is equal to 60 degree. So this kind. So horizontal component H is equal to 20 cos 60 degree. We know that horizontal component is this, then cos 60 degree is 1 by 2, 10 volts. Another component, vertical component, is equal to 20 sin 60 degree is equal to 20 into 0.866. Sin 60 degree is equal to root 3 by 2, root 3 by 2 is equal to 0.866, and 17.32 is our answer. So V1 in rectangular form can be written as, similarly to this, V1 is equal to 10 plus 17.32J, where this denotes imaginary axis. So total horizontal component is, if we combine the horizontal components of V2 and V1, we find total horizontal component is 10 plus 30 is equal to 40, and total vertical component is equal to 0 plus 17.32 आएगा. So V total is equal to root of real component का square plus imaginary component का square is equal to root 40 का square plus 17.32 whole square. By solving this, we obtain Vt is equal to 43.6 volts. So this can be understood by this. The V1 is making an angle of 60 degree. So by parallel shifting, this is shifted to this here, and Vt is the total. So the total horizontal component is 40 and the total vertical component is 17.32. Then by Pythagoras theorem we find Vt, similarly to this. AC source magnitude can be expressed in three ways. So what are these three ways? We learned these in previous classes. First, peak value. Second, average value. And third, RMS value. RMS value is used in domestically. Domestically, we use RMS value. And these two are used for engineering purposes. Various engineering purposes के लिए ये use होता है. So first, maximum value attained. We all know that peak value is the maximum value attained by the AC current. And after that, second, the average value. So suppose this is the half cycle, or we have termed this as alternation. One alternation. Remember that. So we can plot the magnitude of every instant. Let at that instant I1, that instant I2, that instant I3, and so on In. So the average of one alternation, arithmetic average of all values at instant for Positive, only positive means one alternation. So I average is equal to I1 plus I2 and so on In by n. Third, current which flows through a resistor for a given time produces same heat as generated by AC source at a given time. This is for RMS. It is the same amount of current which flows through a resistor or for a given time produces or generated the same heat as it generated by AC source at a given time. IRMS is equal to root mean square, means first of all apply the squares, I1 square, I2 square, I3 square, and then find mean, means a total number of observation upon n, and then apply root. So from end to start you can make this statement. So IRMS is the capability of energy transfer. RMS is always showing the capability of energy transfer in terms of heat, in terms of DC current. So our next topic is what are form factor and peak factors. They are nothing but a relation. These are relationship between IRMS, I average or peak value, or also for ERMS, E average and E peak. For both, IRMS, we know that IRMS is equal to I naught by root 2, and we consider I peak is equal to I naught, and I average is equal to 2 I naught by pi for only half cycle, because I average for whole cycle is 0. So I uploaded separate videos for the derivation of these three quantities, so that you can understand that. Form factor, the ratio of RMS value to average value of alternating quantity. So it is simple, IRMS upon I average or ERMS upon E average. So IRMS की जगह पर अपन ने क्या रखा, I naught by root 2, and I average की जगह पर क्या रखा, 2 I naught by pi. So I naught is cancelled and pi upon 2 root 2. This is a form factor. And then second is peak factor. The peak factor is the ratio of max value. From peak you can remember, peak means the first in the numerator is I naught. The ratio of max value to RMS value of an alternating quantity is called peak factor, is equal to I naught by IRMS. So you can put the value of I naught. There is no value of I naught. IRMS is equal to I naught by root 2. So this root 2 is shifted to numerator and this octet. In this topic we are discussing detail about phasors. What are phasors and what kinds of phasors? Phasors. Alternating quantity can be represented by a line of definite length rotating in counterclockwise direction at a constant velocity. So this we have understand in previous part. So OA is representing that quantity and it is rotating in counterclockwise direction. So this waveform is obtained corresponding to this phasor. So you can understand, when OA is there, then its projection here is this point. When OA is this point is at that point, then the projection is here. When at that point, the projection is there. In triangle OAB, sin theta is equal to AB by OA, and you can obtain AB, so that you can find the magnitude at any instant of time. So AB is equal to OA is equal to max value. When the theta is equal to 30 degree. When sin theta is equal to, when theta is equal to 90 degree, then AB is equal to OA. है ना? Represented in three forms. So phasors can be represented into three forms. So the first is rectangular form. In this phasor is divided into horizontal and vertical components. Which means if V is a phasor, then it is divided into, V bar is a phasor, then it is divided into A and B, where B is imaginary component, you can see there. The magnitude of this phasor is root A square plus B square, similar to Pythagoras. This make a full triangle, and A square, root of A square plus B square give you this quantity. So we find angle theta. Theta is equal to B upon A in terms of tan theta B upon A. So theta is equal to tan inverse of B upon A. If theta is negative, then our vertical component is negative. After that, trigonometric form. After that, the second form is trigonometric form, where horizontal and vertical components of the phasor are expressed in trigonometrical form. So it is similar to the rectangular form. V bar is equal to V cos theta plus J V sin theta, but we have written in this trigonometrical form. Theta is negative, then V bar is equal to V cos theta minus J V sin theta, because the vertical component become negative. Polar form. The third form is polar form. The short form of trigonometrical representation of a phasor is called polar form. It is just a short form of trigonometrical form. So V bar is equal to V angle theta, where theta is phase angle, we know that, with horizontal. If theta is negative, then we apply a negative sign there. We can convert all three into each other, convert into one form to another. So I hope you find it informative. We complete the single phase AC circuit in the next lecture. So the first is rectangular form. In this phasor is divided into horizontal and vertical components. Which means if V is a phasor, then it is divided into, V bar is a phasor, then it is divided into A and B, where B is imaginary component, you can see there. The magnitude of this phasor is root A square plus B square, similar to Pythagoras. This make a full triangle, and A square, root of A square plus B square give you this quantity. So we find angle theta. Theta is equal to B upon A in terms of tan theta B upon A. So theta is equal to tan inverse of B upon A. If theta is negative, then our vertical component is negative. After that, trigonometric form. After that, the second form is trigonometric form, where horizontal and vertical components of the phasor are expressed in trigonometrical form. So it is similar to the rectangular form. V bar is equal to V cos theta plus J V sin theta, but we have written in this trigonometrical form. Theta is negative, then V bar is equal to V cos theta minus J V sin theta, because the vertical component become negative. Polar form. The third form is polar form. The short form of trigonometrical representation of a phasor is called polar form. It is just a short form of trigonometrical form. So V bar is equal to V angle theta, where theta is phase angle, we know that, with horizontal. If theta is negative, then we apply a negative sign there. We can convert all three into each other, convert into one form to another. So I hope you find it informative. We complete the single phase AC circuit in the next lecture.